Hi guys, Assalamualaikum and good day. So today we are going to continue with lecture 3 of FAST, still on 7.1 limits. So the learning outcome for this lesson is, the first one is to find one-sided limit, which is, it will be from the right side, here will be denoted as positive, and from the left side, which is denoted by negative. And then we are going to determine the existence of limit. So for this existence of limit, we are going to use this condition where the limit from the right side should equal to the limit from the left side. So if we have the same value for both left and right hand side limits, means that the limit exists. Okay? So one-sided limit. Before we discuss one-sided limit, we will first look at the graph below. So this is our function fx equal to x cubed minus 8 all divided by x squared minus 4. So this is the form. You can see that at x equal to 2, the y here is equal to 3. It's not included in the graph. Why? If we substitute 2 in this function, what we will have? We will have 0 over 0. So it's not exist, okay, undefined. So this is the graph. If you see that the value here is empty dot. Empty dot means that there is no point there. Okay, so what can we say? We can see that the limit of fx is equal to 3 if x approach to 2 from the right side. Okay, this graph is approaching to 3. The value of y approaching to 3, sorry, from the right side here. From the right side of 2, the value of y is going to the function. The graph here is approaching to 3. And from the left hand side, it's also going to, when x approaches to negative 2 from the left side, the value of y also approaching to 3. Okay, so the limit here is the same, right? Okay, but this is what we call as one-sided limit. Okay, therefore the limit is graph in the graph is two-sided. Okay, so to find each of the sides of the limit, we need to find out from the left side and from the right side. So let's say this graph, so we have function gx equal to 1 plus x all to the power of 1 over x. So this is the graph look like on the x and y axis. So if you see that the graph is starting from 0, where 0 is not included, we have empty dot here. Okay, so limit of this function gx as x approaches to 0 from the right is there, 2.718. If we substitute the value of 0, we get that value. But from the right side, because it's approaching, we look at the behavior approaching. Okay, let's say we have x equal to 0.000001. So it's approaching to this value 2.718. But the limit from the left side of gx is not exist. Okay, so we don't have value of x approaching to 0 from the left side. Therefore, we don't have the value of y when x approaches to 0 from the left side. We said that the limit is in the graph is one-sided. Okay, so one-sided limit can either be a right-hand limit or left-hand limit. So not every function has both side limits. Okay. Right-hand limit, so limit of fx as x approach to a from the right side we denote as positive is equal to L. The limit of f as x approaches a from the right is L. And left-hand limit, when limit of fx as x approach to a from the left side, so we have negative sign here equal to m. So the limit of f as x approaches a from the left side is m. One-sided limits are useful in taking limits of function involving radicals. Okay, what it means by radicals? Okay, for example, refer to the diagram. Find limits of function below. So we have this graph and we want to find the limit as x approaches to a certain value. Here, for the first question A, we have x approaches to negative 2 from the left side. So where is negative 2? Negative 2 here. So do we have any function, any graph plotted as x approaches to negative 2. So if we see here, from the left side, we don't have any graph. So we can say that the limit of fx as x approaches to negative 2 from the left side does not exist. How about question B? Question B asks you to find the limit as x approaches to negative 2 from the right side. So where is the right side of the graph? It's here. Okay, so as x approaches to negative 2, the graph is approaching to, what is this value? So this graph is approaching to negative infinity. Okay, you can see that the graph is going down but not approaching this asymptote, this straight line, vertical line. Okay, this vertical line, it will not approach lah, because this means that this line is an asymptote. Okay, next, as x approaches to 0 from the left side. So from the left side of 0, so where is the left side of 0? So it should be here lah, the value of x. So as x approaches to 0, the graph here approaching to 1. So the answer is equal to 1. And then how about the limit of f as x approaches to 0 from the right side? So the right side of 0 will be here. So our graph will be around here. So the graph is approaching to, also approaching to 1. So in some parts of the graph, it may have both-sided limit or it may have only one-sided limit. Okay, so one-sided limits are commonly used to evaluate limits of a piecewise function. Okay, so find example 2, find limit of fx as x approaches to a from the right side and limit of fx as x approaches to a from the left side for a given value of a. Okay, so for question A, fx equal to a function of 2x minus 1 as x not equal to 1 and 0 is x equal to 1. So this x not equal to 1 and x equal to 1 is the domain. So for the domain x equal to 1, we use function 0. For the domain of x not equal to 1, so other than 1, we use function 2x minus 1. So let's say our a is equal to 1. So how do we find the limits on both sides? Okay, so this is our line at a equal to 1. So our graph at a equal to 1, the fx is equal to 0, right? At that point, a equal to 1. Okay, that's why it's dash dot here. And then for x not equal to 1, so other than 1, so this side and this side, the right side and the left side of 1, the function is 2x minus 1. So what is the limit of fx as x approaches to 1 from the left side and the right side? Okay, so from the left side, it's going to 1. So the function here we can use is the function of 2x minus 1 because it's approaching to 1, right? The left side of 1. So 2x minus 1, it's not exactly at 1. So we only directly substitute. We know that which function we should use. So we have to substitute the value of x a here lah. So 2 multiplied by 1 minus 1 is equal to 1. How about the right hand side? It will be limit of fx as x approaches to 1 from the right side. So the right side of 1. So we should use the function on the right side of 1, not exactly at 1. So the right side of 1 here is a function of 2x minus 1, the same as the left side. So after we find out which function we should use, we just substitute the value of a inside the function lah. So we have also equal to 1. Okay, but exactly at a equal to 1, fx itself, fx or f1 itself is equal to 0, which is not equal to the limit lah, when approaching to 1. So we can see the behavior of the limit compared to the exact value of f as x approaches to a, as x equal to a. So for question B, so let's say our fx is a piecewise function consists of 3x squared minus 6 for x less than 2 and 8 minus x as x approaches more than or equal to 2. So we want to find the limit at a equal to 2. So we find out from the left side and from the right side. So left side of 2, we have a function of 3x squared minus 6. So this is the domain for x less than 2. For x more than or equal to 2, we have a function of 8 minus x. Okay, so we catch just like in the function, so we can know which part of the piece that we use the certain function. So for the left side of 2, so which part of the left side of 2, we use the function 3x squared minus 6, where x less than 2, and then we just have to substitute 2 into the function. We have 3 of 2 squared minus 6. So 3 multiplied by 4 is 12. 12 minus 6 is equal to 6. Okay, so this is from the left side of 2. How about the right side of 2? The right side of 2, we are using the function 8 minus x, right? Right side of 2. So, we substitute the value of 2 into the function. We have 8 minus 2 equal to 6. So, the limit is the same from the left side and from the right side, even though they are consist of different type of function. Okay, it's just coincidence, huh? It's not true. It's not always true for all type of function. It's just for this type of function, the value is the same.
Okay, so let's say example 3. So we have to find the limit of fx as x approach to negative 2 from the right side and limit of fx as x approach to negative 2 from the left side for fx equal to absolute x plus 2 and divided by x plus 2. So what is the special here is that the function consists of absolute notation. Okay, first of all, to make it easier, you have to define the function first. Define into piecewise function because it consists of absolute notation. Okay, but we can see the solution below. So for the left side, for the limit of fx as x approach to negative 2 from the right side, okay, if you use the definition, by substitution, we directly get 0 over 0. So we need to factorize. But how to factorize? Okay, that's why we need to recall back the notation, the function, the absolute function. So for absolute function here, we can divide it into two parts, which is the positive and negative part for a certain domain. Okay, for here, x, absolute x is equal to x, where x should be more than or equal to 0. Why? Because it's positive x here, so inside here also should be positive. Positive, positive will be 0. That's why x should be more than or equal to 0. This means positive. And then it will be equal to negative x for x less than 0. Why negative x? Because this x is a less than 0, means that it's a negative number. So negative multiplied with negative will be positive. That's why absolute always positive. Okay, so first we define it. Okay, so fx is equal to absolute x plus 2 all over x plus 2, right? So to define what we will have absolute x plus 2, it can be divided into x plus 2 and negative of x plus 2. For x plus 2 more than or equal to 0 means that x should be more than or equal to negative 2, and negative of x plus 2 for x less than or negative 2, less than negative 2. So means that our fx will be, so the first one, for x more than or equal to negative 2, we use the function x plus 2 over x plus 2. X plus 2 divided by x plus 2. And then the left side of negative 2, we use the function of negative x plus 2 divided by also. It should be terbalik here. So it should be negative of x plus 2 divided by x plus 2. So if we see, this x plus 2 over x plus 2 can be simplified into a function of 1. Here will be x plus 2 divided by x plus 2. It will be negative 1 after we simplify it. Okay, so we can directly substitute into the function for fx, for limit of fx as x approach to negative 2 from the left side. So from the left side, we use this function. So it should be negative of x plus 2 over x plus 2, which is equivalent to negative 1. So the answer here is negative 1. But from the right side, limit of fx as x approach to negative 2, we actually find a limit of function x of plus 2 over x plus 2, which is equal to 1. So limit of 1, limit a constant, it will be 1. So the answer here is equal to 1. Okay? So For example 4, the function f is defined as, so we have a piecewise function here for how many intervals? So x less than 3, x equal to 3, x in between 3 and 5, where 5 must be included, and x is more than 5. So we have how many questions they ask you to find? We have here limit of fx as x approach to 3 from the left side, approach to 3 from the right side, approach to 5 from the left side, and approach to 5 from the right side. So let's see one by one. For x approaching to 3 from the left side, so the left side means that we have to use the interval x less than 3. So the function that we will use is x squared plus x minus 12 over absolute of x minus 3. So let's substitute directly. Okay, so if we substitute directly, what do we get here? Is 3 squared plus 3 minus 12 equal to 0, and 3 minus 3 also equal to 0. 0 over 0. So by substitution, we cannot solve this limit. So what we need to do, we either have to factorize or conjugate. But here we don't have any. We don't have any surds. Yes. So we cannot use conjugate lah. So factorize out this. We have x squared plus x minus 12. Since x equal to 3 is the factor, so x minus 3 will be the factor of x squared plus x minus 12. Directly, you can factorize by using your calculator. We get x minus 3 multiplied with x plus 4 and divide by x absolute of x minus 3, which is an absolute function. We can divide into the piecewise form. So it will be x minus 3 for x more than 3 or equal to 3. And negative of x minus 3 for x less than 3, the domain. So here is left side of 3, right? So left side of 3 means that we have to use which one? So we have to use the second one, which is negative of x minus 3. So we are dividing with negative of x minus 3. So simplify this expression. What do we get? It will be a negative of x plus 4 only. Okay? So negative of x plus 4. Okay, so substitute the value of 3 into the function. We get negative of 3 plus 4, which is negative 7. Okay, so this is for the first part of the question. The second part of the question, to find the limit of fx as x approach to 3 from the right side. Okay, so from the right side, which function we should use? From the domain, we can see that the right side of 3 is equal to which function? Yes, x plus 5. So substitute directly 3 into the function. We get 3 plus 5 equal to 8. Directly we get the answer. Okay, so the next question. Limit of fx as x approach to 5 from the left side. So from the left side, which part? Which domain? So it should be the third domain, right? So the third domain means that we use function x plus 5. So substitute 5 into that function. We get 5 plus 5 equal to 10. Okay, and then the last one, limit of fx as x approach to 5 from the right side. So right side of 5, which domain? So it will be the fourth domain, right? So the function here is a constant function 10. So directly the answer is equal to 10. Okay, so this is question example number 4. Let's continue with the next part of this lecture. Test for existence of a limit. Okay, so this is the concept of existence of limit. The existence of limit, whether the limit exists or not at a certain point. Okay, so if limit of fx as x approach to a from the right side is equal to the limit of fx as x approach to a from the left side, which is equal to a certain value L, then the limit of fx as x approach to a exists, which is equal to L. Okay, so this L is the turning point of a piecewise function. So the value that will separate between the piecewise function. Okay, so let's see example 5. Given fx is equal to 2 when x is less than 1 and 5 when x more than or equal to 1, find the limit of fx as x approach to 1. So actually we can directly substitute, right? But because they give you in a piecewise function, so we need to check from the left side and from the right side. So from the left side of 1, we have a function of 2, right? And from the right side of 1, we have a function of 5. So when x approaches to 1 from the left side, the answer is equal to 2, right? Function 2. So the answer directly, because the constant, it will be equal to 2. And for the limit of fx as x approaches to 1 from the right side, the function we use is 5. So limit of 5 as x approaches to 1 from the right side, because it's a constant value, so directly is equal to 5. So how to find the limit of fx as x approaches to 1? Since the value of the limit from the left side of 1 and the right side of 1 is not the same, means that the limit does not exist. So we don't have the limit for x approach to 1. Okay, so what is the difference between this question and the first part of the chapter limits? For the first part of the chapter limit, want to find limit, we just substitute, right? But now, because we have this piecewise function, we cannot directly substitute. Okay, we need to see the behavior from the left side and from the right side. Okay, example 6. Given hx as hx equal to 4 minus x squared for x less than or equal to 1 and 2 plus x squared as x more than 1. So if I be you in the exam, so I will sketch the graph first. The left side of graph including 1 is 4 minus x squared. The right side of the graph of the 1 as and 1 is not included, it will be 2 plus x squared. Okay, so find the limit of hx as x approach to 1. So we need to find from the left side and from the right side. Okay, so this is our graph, not graph, just representation of the function on the real number line. Okay, so from the left side, we use a function of 4 minus x squared. So substitute value 1, we get 4 minus 1 squared, which is equal to 3. And from the right side, we have a function, yes, 2 plus x squared. So substitute 1 into the function, we get 2 plus 1, which is equal to 3. So since the limit from the left side equal to hx as x approach to 1 from the left side equal to 3, which is equal to the limit of hx as x approach to 1 from the right side, means that the limit of hx as x approach to 1 is equal to 3. Okay, let's see example 7. So given that fx equal to ax plus 5 for x less than or equal to 1, so this is piecewise function, and x squared minus 1 as x more than 1. So if limit of fx as x approach to 1 exists, determine the value of constant a. What it means by exist means that we can apply the definition of existence of limit, where the limit from the left side is equal to the limit from the right side. Okay, so what is the limit from the left side? The limit of fx as x approach to 1 from the left side, so it should be the less than 1. So the function is ax plus 5. So we get limit of ax plus 5 as x approach to 1 from the left side. And then from the right side, we should take the domain where x is more than 1. So the function is limit of x squared minus 1 as x approach to 1 from the right side. So after that, we just directly substitute the value lah. So what is the value we need to substitute? Yes, 1. So substitute 1 on both sides. So we will get 1a plus 5 equal to 1 squared minus 1. So we get a plus 5 equal to 0. This one is 0. So a is equal to negative 5. So we have the answer for example 7, which is the constant a since the limit exists. Example 8. Given that hx is equal to 20x squared minus k, where x is less than 4, and kx cubed minus 5 for x more than 4. Determine the value of k such that the limit of hx as x approach to 4 exists. Okay, so we have a function of 20x squared minus k on the left side of 4 and kx cubed minus 5 as x more than 4. So to find the limit to find the value of k, we can use the existence of limit, where the limit from the left side equal to the limit from the right side. So what is the limit from the left side of 4 and the right side of 4? So for the left side of 4, we have 20x squared minus k. So it will be limit of 20x squared minus k as x equals to 4 from the left side, and limit of hx, which is the right side, equal to kx cubed minus 5 as x approach to 4 from the right side. Okay, so what we need to do now, we just substitute the value of 4 lah. So it will be 20 multiplied by 4 squared minus k equal to k multiplied by 4 cubed minus 5. So what we have here is equal to 4 squared is equal to 16. 20 multiplied by 16 is equal to 320 minus k, and the right side 4 cubed is 64, so 64k minus 5. So what do we have here? K, 65k is equal to 325. So k is equal to, what is k? K equal to 5. So we have the answer for k here by using the existence of limit. So it's really easy. For this lecture, we just need to know how to find the limit from the left side and from the right side. So what we have to remember is to apply the, usually we need to apply the absolute definition, absolute function. Okay, we have to make it into a piecewise form, and if there is no absolute nothing, just use the piecewise function, determine which domain we should take the function. Okay, nothing extraordinary, just applying what you learned in chapter 5. Okay, so that's all for this lecture. Hope you guys continue with the tutorial. Okay, thank you.